recorded 2 videos, so I think they are enough for you to do some of the questions, right? Okay, so this topic is about kinematics. Oh, hold on.
Okay, kinematics. Yeah.
So for kinematic,
Sounds so similar to.
so definitely you will have one question on kinematics. Okay, so that is usually like more than 10 marks, 10 to 15 marks already.
What?
Okay, so
15.
kinematic. So there are 2 parameters you need to know. One of them is displacement, then the other one is velocity, and the last one is acceleration.
So it's like, is it similar to physics?
Okay,
or?
then they are related. Okay, they are related. Okay, so just remember kinematics. But over here we use differentiation and integration.
For kinematics.
Yes. Okay, so the rule is if you differentiate with respect to t, you will get velocity. If you differentiate velocity with respect to t, you will get acceleration. Okay, so therefore differentiation is the opposite of integration, right? So therefore if you go up, if you go up, so basically you integrate with respect to dt, you integrate acceleration, you will get velocity. You integrate velocity, you will get displacement. Okay,
that makes sense.
okay. So with this, that's it already. Okay, so let's try out one question. Probably try out
So this is like the main concept.
Yep, the main thing. Okay, let's do B3.
Is it?
No, I need to. Oh, okay. I make a mistake. I just need this part. Okay, so the question gives you what? The question says a particle travels in a straight line so that t seconds after passing a fixed point O. So basically you have a point O.
And then the particle travels in a straight line.
Yeah, point O. Then here. And the displacement is given by this. So that means at t equals to 0, where is your... So at t equals to 0, your particle is here. Okay, point O. Then after that, then the displacement is given by this formula. How am I so fat?
Because you zoom in so much.
Yeah. Yes. Okay. So the initial displacement of the particle. So what's the meaning of the initial displacement of the particle? What's the meaning of the initial?
At the start where t
equals to 0. Yes. So whenever you have the word initial, right? So t equals to 0. So when t equals to 0, you sub in. So you want to see whether the particle start from point O or it start from somewhere else. Okay. So you put t equals to 0 in, you get 0. 0 times 3 is 0. 0 times 9 is 0. 4. Okay, so therefore your displacement is 4. So what this means is the particle doesn't start from point O.
Yeah.
It start from, if this is point O, it start from
4 meters.
4 meters away. By the way, this is plus 4.
Yeah.
So it's on the right hand side.
Yeah, I
okay. So therefore, at t equals to 0, this is where the particle is.
Yeah.
Okay? And this is your point O. Okay? So therefore the initial displacement is 4. Okay? Meters. Okay? The value of t when the particles is instantaneous at rest. You know what's the meaning of instantaneous at rest? At rest, I think you know, right?
Yeah.
At rest means the particle is not moving.
That means immediately at rest.
Yep, immediate at rest. So you have displacement, which is denoted by s. You have velocity, you have acceleration. So instantaneous at rest, which one you should use? Think about physics. Instantaneous at rest, what's the meaning of that? At rest means what?
At rest means acceleration is 0, velocity is...
Acceleration is 0. When the acceleration is 0 when it's at rest,
Yeah.
then you don't know about physics then. At rest means the thing is not moving.
Yeah.
The thing is not moving, so there is no, so the velocity is 0. You know why acceleration is not equals to 0 can mean something else? Acceleration is 0 means...
means velocity can be constant.
Correct! So the
Oh,
velocity
yeah.
can be 6
But acceleration can also be 0.
and it remains at 6 for acceleration equal to 0.
Okay, yeah, it's
Okay?
right, yeah.
So therefore, like I say, when it says at rest means v equal to 0. Your part 2. Okay? So the value of t when the particle is at rest. So basically, this means v is equal to 0, right?
Mm.
So how do you get v equals to 0?
Differentiate
Differentiate the s. Okay? So you differentiate the s. Okay? Then you will get your v, right? Okay? Then you just equate your v equal to 0 because the question wants v equal to 0. Okay? So you differentiate this. So the first one you get 3t, 2. This one you get minus 6t. This one you get minus 9. That's it.
Oh yeah.
So you equate it to 0. So this is quadratic equation. So for this quadratic equation, I think you can take out but you can take out the 3.
T square minus
It simplify
2t
your
minus 3.
your question a lot, right?
Yeah.
Get rid of the 3, divide by 3. Then it's t minus 3 and t plus 1. Then
So
therefore
t
t
equals
equals to
3
3,
or
t equals to
t
negative 1. And time cannot be negative, so you reject, right? So you must state the reason, huh?
Yeah.
Okay, I don't want. So that means the time is 3 when it's at rest. So now you make use of the displacement graph just now. When this is point O, at t equals to 0, is 4 meter away, right?
Yeah.
From the point O, right?
Yeah.
So now at t equals to 3, so basically this tells you your particle at t equals to 0 is here, right?
Yeah.
Then at t equals to 3, your particle stop. So this shows the particles move in one direction. Oop, t equals to 0, stop. Right?
T equals to 3, not 0.
Or t equals to 3, the particle stop, right?
Mhm.
So you stop here, right? So you can actually find out whether the particle move to this side or this side by substituting the t equal to 3 into the displacement equation. So can you help me out? So s equals to 3 to the power 3, 3 to the power 2, 3 plus 4. So what's the answer? I sub the t equal to 3 into the displacement.
Negative 3.
Negative 23.
3.
Oh, so therefore the
It
particle
move back.
the particle doesn't not move back. It start from here. It doesn't go to the right.
Yeah.
It go to the left. And at t equals to 3, the displacement is always from the point O, right?
Yeah.
So basically it is 23, right? So that means here to here is 23. Here is where the t equals to 3 is. So therefore, this is 23 and this is 4. So in a way, right, from t equals to 0 to t equals to 3, the particle has traveled 27 meter. Does it make sense?
Yeah.
Okay? So the distance traveled by the particle in the first 4 seconds. Okay, never mind. So t equals 0 is here. T is equal to 3 is here. but they want the distance travel not in the first 3 seconds. If it's in first 3 seconds, the answer will be 27. They want 4 seconds.
So you sub in.
So you sub in t equals to 4. Where is it? So instead of 3, it's 4, 4, and 4.
Negative 16.
Negative 16?
Yeah.
Okay, by the way, this is 4, not 9. Huh?
Yeah.
So it's negative 16. So you just make use of the displacement graph.
So
t equals to 4 is negative 16.
So, 16.
So that means here to here is 16, right?
Yeah. So 16 plus 4.
Here, right? Hold on. Now,
Okay.
for this, I need you to, okay, so this is 23. I need you to tell me the trajectory, how the particle moves in the first 4 seconds. Then only you will know the distance.
Oh yeah, because it goes from there.
Yeah. So first, so first you go here, right?
Yeah.
Then it comes back to
the
here.
Yeah. Oh,
then
so you need to add that part.
Correct. So
oh my god.
You need to make use of the displacement trajectory to find out the distance. How? You need to find the trajectory. From T0 to T3 is 27. Right?
Yeah.
And then because of when T equals to 4, the displacement is 16. Right?
Yeah.
So what is this part? So basically the particle come back to here lah.
So it's 23 minus 16, 7.
Which is 7 here, right?
So 7 plus the 27.
Correct. So it's 27 plus 7, that will give you 34.
34.
So that's the distance traveled in the first 4 seconds.
Wow.
Okay?